So today we want to talk about parabolas, our first conic section. And to understand what we're talking about as far as conics are concerned, if we take two cones and we put them point to point, we can find out what the Greeks, the ancient Greeks, were learning about. So first of all, let's pull this in and watch this. And so if we take those cones, those two cones that are put together point to point, and we run a plane through them, we're going to get some different things. So when we run a plane through, we're going to rotate those, so we've got our cones. It's called a double cone. And when we take planes and go through at a cross section, if we happen to go parallel to the cone space, we end up with a circle. Okay? If we go at a slant, we end up with not a circle, but an ellipse. When we go at an angle that only intersects one of the cones, we end up with a parabola. And then vertically through both cones, we get something called a hyperbola. Okay? So those are our four conic sections. Obviously, if we go straight through the middle, we're going to get just a point, right? And so forth. All right, so there are three approaches to talking about conic sections. One is the Greek approach. The ancient Greeks used those two cones together with planes cutting through them. The second one, and by the way, it's a double napped cone not passing through the vertex. Okay, so of a double cone, we call it double napped cone in our book. Algebraically, we can talk about them as well, where we have an ax squared plus a bxy plus a cy squared plus a dx plus an ey plus an f equals 0. Don't worry about this equation. Just want to show you those kinds of things, those two things. The third one is talking about a set of points that satisfy a particular geometric property. And that's what we're going to be working with. For example, if you have a circle, we have an equation that says y minus h quantity squared, x minus h quantity squared, plus y minus k quantity squared is equal to r squared. That's the set of all points that are equidistant from a fixed point h and k. And that distance is r. That's the approach that we're going to take. We're not going to be taking two cones, double napped cones, and sliding planes through them. And we're not going to use this algebraic approach. We're going to talk about them as being a locus of points. Okay? Again, this is not a lot of stuff to write down, just more information purposes. Your problems won't directly relate to this. All right, so next slide talks about parabolas, and this is what we want to write down. So a parabola is a set of points, or a locus of points, x, y, in a plane that are equidistant from a fixed line called the directrix and a fixed point not on that line called a focus. So parabola has the shape itself plus a focus and a directrix. The points on that parabola are equidistant from the focus and that line called the directrix. So in the past, when we were talking about parabolas, we talked about its axis of symmetry and its vertex for the most part. And we found points that satisfied our equations. Now we're going to find that focus and we're going to find that directrix. And that has lots of uses in real-world applications. I have a neighbor who is an engineer, lives right behind me. He said his first job, once he got out of college, was to design a parabolic light so that when it focused the light, it would focus it on a particular point. Okay? So he had to figure out what would be the best parabola to use for that in order to get to his constraints. we can do the same thing if we want to build a solar cooker. What's a solar cooker? A solar powered cooker, right? We can use a parabolic figure to cook a hot dog and see if we can get the hot dog's temperature to increase. Okay? All right, so this distance from the focus to the parabola is the same distance from that point on that parabola to the directrix. Okay? All right, so how to create a parabola. Just want to show you what this looks like. So we've got a focus, we've got a midpoint, that was the vertex there, and we just stretch it out. So if we had a rubber band that stretched it evenly between the focus and the directrix, we're going to have a parabola that gets created. Those two lines are always going to be, or those two segments will always be equal in length. Okay? All right, so the focus is always where with respect to the parabola? What do you think? Where's this focus? Above or inside? Inside the parabola? Okay, so the focus is always going to be inside the parabola. The directrix will always be below or outside of it. And we shouldn't really say below, because what if our parabola was reflected down? Okay, so directrix is always going to be outside the parabola. Okay. Here's our line of symmetry. So the directrix is always what with respect to the line of symmetry? 90 degrees perpendicular. Okay, so it will always be perpendicular to the axis of symmetry. And that will help you so you don't have to memorize all the little intricate parts of the formulas. Okay? So the standard form of a parabola. And this is standard form as our book calls it. Okay, we're going to think of it as vertex form. If the parabola is vertical, like we've been used to seeing, then it will be x minus h quantity squared is equal to 4p times y minus k. P is not equal to 0. Your vertex is hk. Your directrix will be y equals k minus p. And your focus will be the point h comma k plus p. So p is just how far that focus is away from the vertex and how far that focus is, the directrix is away from the vertex. Okay? Don't concern yourself so much about which one's plus and which one's minus, because we're going to remember focus is always inside, directrix is always outside. Ready for the next slide? Not quite. Actually, it's not the next slide. We're going to talk about the next half of it. So this is vertical. If it's reflected, what's going to make it reflected? What made it open up? We're used to seeing y equals a x minus h squared plus k, right? Okay, that was our vertex form of a parabola. What made it open up? the A, right? A was positive, right? So when 4p is positive, it's going to open up. But if 4p is negative, okay, or p is less than 0, then it's going to open down. Make sense? All right, that's the vertical. All right, our book is going to call the horizontal standard form as y minus k squared. Our y is now the squared term, equals 4p times x minus h. Or again, p can't be 0, so we don't get a parabola. Okay. Vertex is still hk. The directrix is now x equals h minus p. And the focus is the point h plus p, comma k. But again, don't focus so much on how to get the directrix and focus from the equation, because we're going to talk about the focus being inside and the directrix being outside, p units away. So it's not going to be a lot of formulas to memorize. So it will look like this if p is positive, opening to the right. What would make it open to the left? P is negative. Okay. All right, I think everybody's finished writing. Okay, so we're going to sketch the graph of y squared equals 3x. And we're going to find the vertex, the focus, and the directrix. Okay? So first of all, y is being squared, right? Is that opening up or down or left or right? Left and right, okay? So is it left or right? Right. Why is it right? Yep. Okay. So it's going to open to the right because we have a positive 3x. Okay. Now, let's think about this in terms of its formula. This would be y minus what squared? Are you okay with 0 there? Okay. Equals 3 times x minus 0. Because there's really nothing with it. If we want to write it in our form of y minus k squared equals 4p times x minus h squared, there's nothing with that y squared, right? So 0 is our k. There's nothing being subtracted or added to our x, so 0 is our x. So where's our vertex? The origin. Yep. Excuse me. Thank you. Okay, vertex at 0, 0. So next step. We know it's opening to the right. Okay. So we need to figure out what our 4p is. Well, 4p is this 3, isn't it? So if we divide by 4, what is p? 3/4. So that means that our focus is 3/4 of a unit away from our vertex. So 3/4 of a unit, and we said it's opening to the right, we're going to be right here at 3/4. And our good question. So we have it almost in our perfect form, right? Y minus k squared equals 4p times x minus h squared, or not squared, just plain old x minus h. Okay, so our 4p is actually equal to good old 3. Okay, that's the number that's being multiplied by the non-squared term. And when we divide, we say 4p equals 3, and we have to get the p by itself, we'll divide by 4. So our focus is really close to our vertex. Where's our directrix going to be? Same distance away, right? So 3/4 in the opposite direction, isn't it? So this is going to be our directrix. And it's always perpendicular to our axis of symmetry. Our axis of symmetry is our x-axis here. Okay, now we're just going to do a quick sketch of this, and then I'll show you how to find some more points on the next one. So a quick sketch means, guess what? Going from the vertex, opening to the right, we have our focus. It's a point 3/4 over 0 up. We have our directrix, which is a line of what? Negative 3/4 is equal to x. Okay, so if you remember, the focus is always on the inside, the directrix is always on the outside. P units away, you don't have to worry about whether it's plus or minus and so forth. They are always the same, because the definition of a parabola is every single one of these points along this parabola has to be the same distance between that focus and the perpendicular distance to that directrix. So those have to be the same distance. Okay, great questions. Other questions on this slide? Okay, so the directrix is going to be exactly the same distance away from the vertex as the focus was. So when we found out that we needed to move 3/4 of a unit away from the vertex to find our focus, we moved 3/4 of a unit away from the vertex to find the directrix. Okay, a lot easier than worrying about formulas and memorizing. Okay, and then it's just a line. Okay, other questions about this slide? All right, let's look at another example. Now we're going to find the graph, or sketch the graph of 0 equals y squared minus 4y minus 4x. And find the vertex, focus, and directrix. So in our previous equation, we had a y squared, right? This time we have a y squared, but it's not in a form that we can use yet, is it? So we want to put it in standard form. What do you think my first step is going to be to get that in standard form? Good. Get something to the other side. So these guys are already on one side. Let's take that 4x to the other, the negative 4x to the other side, so that it's away from the y's. So y squared minus 4y will be equal to a positive 4x now. Now remember back to semester 1 when we had to complete the square to find the vertex form of our parabolas? We had to ask ourselves, what is 1/2 the middle term squared? Right? So negative 4 divided by 2 is negative 2 squared is going to be a positive 4, right? So if we add 4 to this side to make a perfect square, then we have to add 4 to this side to make a perfect square as well. half the middle term squared. Yep. So that negative 4y, the half of b, if you want to think about it as b here, 1/2 of b squared. Okay. So now we have a perfect square on the right-hand side. That perfect square is y minus what? 2, because it's y minus 2 times y minus 2. And it would be nice if we had our 4p out in front, right? So let's factor out the greatest common factor. And this will be x plus 1, right? Okay. Thank you. So now we have our h and k, don't we? What's our vertex? Because we have it in the form of 4p times x minus h equals y minus k squared. So what was our vertex? -1, +2. Always the opposite signs of what's in the parentheses. So we are at -1 up 2. Which way is this one opening again? Our y is squared, so it's opening left to right, correct? So, and our 4p is positive, so it's opening right. Okay. And what is our p? So our 4p is the number that's in front of the non-squared term. So if 4p equals 4, what's p? Yep. So that means that we're going to move 1 unit away from our vertex. And that's our focus, 1 unit to the right, because it's always inside. 1 unit to the left is going to be our directrix. And then the easy way to find 2 other points is just to double p. If we double p, we're going to get what? 2. Okay? That means we're going to go 2 units from our, make sure I tell you this right, 2 units from your focus. 2 units down, 2 units up, and this is how your parabola is going to open. That's a trick, because it's going to make it exactly 2 units this way, 2 units this way. Do you see how this point is equidistant from both the directrix and the vertex, and the focus? So double your p and move that distance up and down from your focus. Then you can plug in points. They won't be nice and neat. Okay. So what's our directrix? X equals -2, because it's a vertical line, so x equals, and we were at -2. And what's our focus? Yep. No formula memorization, just know the 4p and how to complete the score. All right, one more example. All right, so we want to find the focus for directrix and vertex of this mess. and sketch the graph. So what do you think the first step will be? Get it in the right form. And we've got a mess there with that negative 1/8, right? That's going to be part of our p, isn't it? So let's get rid of that. When we have multiplied by a negative 1/8, we want to get rid of it. We do what? Divide by negative 1/8, right? Which is the same thing as multiplying by negative 8 over 1. Yep. So we'll multiply this side times negative 8, multiply this side times negative 8, and we have a negative 8y is going to be equal to x squared plus 2x plus 33. That 33 is not really helping us out either, is it? So let's take it over there so it can become part of the k. And we'll have a negative 8y equals x squared plus 2x. If we take the 33 over, we'll have a negative 33 on the left side. All right, so we want to complete the square. What's going to make a perfect square on the right-hand side? One. So if we add half of the middle term, half of 2 is 1, squared is 1. We're going to add 1 to both sides of the equation to balance it. Because we want to make this a perfect square, so it can be an x plus or minus something quantity squared. Okay, that way we can find our vertex. So this is x plus 1 quantity squared, and this is negative 8y minus 32. So I take that negative 8 out. Okay, got an assignment for you. It's on the blog. I can flip to it real quick. Okay, take a quick photo of it and do what you can with these.
Maddie Higby, David Watt, Madison Maddox, please come to the front office. Jake Singh.